Well, hello and welcome to another Clyde Cruising Club presentation. This one, anchoring, anchors and anchorages. This presentation is being recorded in order that others might be able to view it later on. How this works is I'll be sharing the screen like this with you so that you can see the presentation as it's showing on my screen, and I'm going to just talk over the top of the various slides that I have. Firstly, I start with a declaration of interest. I happen to be involved in manufacturing and selling of anchors for leisure boats, but this presentation is not an advertisement for any brand of anchor and avoids naming any particular brand as being a superior one. That said, let's move on to what we're going to cover. The presentation will cover anchors, anchoring, and anchorages, and under each of those headings, those three sections, we'll cover the history of anchors, where did they come from and how did they develop, how do we measure relative performance between different anchors, what's the sort of measurement of performance that we might use, how do you measure a performance of something that can be used in such a variety of ways, what about a little bit about science versus tradition. Under anchoring, we'll look at what are the objectives of it, the technique. We'll talk about catenary, we'll talk about rode, holding power and forces on a boat in wind and tide, and systems of checking that your anchor's holding. And then we'll move on to where you might anchor. This is Scotland based, of course, and so we'll be choosing anchorages on the west coast of Scotland and looking at sources of information and what sort of scenery might be available to see. If we go back into history long enough, then we get back to this type of anchor, which was a large weighty stone bored with a hole through it for attaching a rope and just thrown over the side of a boat, a canoe or whatever it might have been. The bottom right-hand one happens to be from New Zealand, and it was used by the original settlers in New Zealand in the 12 and 1300s who came from Hawaiian or thereabouts islands in the Pacific to New Zealand, and they used anchors like this. Essentially a large stone with a hole through it and a rope. And this is probably where we get the idea, this type of anchor, that weight matters. Actually today weight doesn't matter. An anchor can be made out of aluminium and be very light. So what really counts is holding power, but we'll get to that later. The first anchors in the 19th century were like this. You can see that the designs are fairly similar. At the top of the one on the left, you can see a long rod with two eyes in the end, and this was called the stock. Later they developed anchors called stockless anchors, and you might wonder where that term came from. It's ones that don't have this. The purpose of the stock was to turn the anchor so that the flukes, that's the pointy bits, would dig into the bottom. Clearly that's the best way for an anchor to hold, such as this anchor, is for the pointy bit to hold in the bottom. But you can also see that the flukes are pretty tiny. If this was a shovel, it would be ineffective. It's like using a teaspoon for a shovel. And so you can see that weight really mattered in these. And while it is a development of a rock with a hole through it, it has some sophistication. It doesn't actually develop a great deal of holding power unless it hits something like a rock or some other obstruction on the bottom. In soft sand or mud or something like this sort of anchor really doesn't do very much good. These were awkward to stow, the stockless anchor, and so they developed ones that had a folding stock, but the stock was there to rotate the anchor so that the flukes would embed. The Martin anchor on the right had a rotating set of flukes so that it didn't need such a big stock, and the stock was much smaller, you can see here, and the anchor would essentially lie flat on the sea bottom, and as it gets dragged along, then the flukes would rotate into the sand. And this type of anchor is very common on large ships today because it stows very easily, and that's a big issue for an anchor that you can't manhandle. An anchor of several tons needs to be able to stow almost automatically as it comes aboard the ship. So for our types of size boats and leisure boats, both of these sorts of anchors had their place and had their day, but so did the steam engine. Move on to the 20th century, and in 1933, Geoffrey Taylor of England developed a CQR anchor. So between the two wars, this anchor was developed, and it was very effective for its day. It had a large plough shape that embedded into the seabed and a hinge on it so that the plough would always engage. Naturally, it wouldn't fall in the way that it's pictured on this screen. It would fall on its side. But on its side, with that hinge and the angle that was there, the tip of the plough would engage the seabed and the thing would hopefully embed. And this was developed a lot more holding power than the previous types of anchors we looked at. Also on the left, the Danforth, another 10 years later or so, Richard Danforth, during the Second World War, developed this type of anchor, and this was developed specifically for stowage. So this anchor folds flat. It's similar to the one that we saw earlier, the Rogers, where the flukes are hinged in respect to the shank. And so when it lies on the seabed in this orientation, the way you see it, then the tips of the flukes should embed. This anchor is still one of the better performing of those from the 20th century. And of these four anchors, the Danforth is probably the one that develops the highest holding power, but only in certain seabeds. If it's a rocky seabed, then it's almost useless. During the 1970s, Peter Bruce from the Isle of Man developed the Bruce anchor, and these are quite commonly found on leisure boats even today. These are made of a single piece of steel in a forged method of manufacturing, and these were largely developed for oil rigs in the 70s and were made in very large sizes. Smaller scale ones were made for leisure boats. These were a reasonably effective anchor and developed a similar holding power to the CQR. During the 1980s, somebody decided that the CQR was a bit of a hazard in terms of the hinge, and very easy to trap your finger in the hinge if you start manhandling the anchor. And a few pinched fingers, even lost fingers, caused people to think of a way of doing away with the hinge, and that led to the development of the Delta. So this is really a modified CQR, plough type anchor with no hinge. They reduced the manufacturing costs by not using a forged plough and used a folded, welded sheet metal plough arrangement. Delta is still widely available today, so is the CQR, so is the Bruce, and the Danforth for that matter. Many boats still use these. However, like in all things, technology moves on and people apply their engineering expertise to things, and we come to the 21st century and a series of what are euphemistically known as the new generation of anchors. Here we have 6 examples, and there are others. Some of these have advantages over the others, and some of them perform better than others, but they all perform a lot better than the previous ones that we've looked at. The difference in performance is about 4 or 5 times between the 21st century anchors and the 20th century. The spade at the top left is a French invention. The bugle is a German, Manson Supreme, not sure where it came from, but that's a fine anchor as well. Rockner is fairly commonly available all over the world, now owned in Canada, originally from New Zealand and made in China. The Mantis, it has the advantage that you can take it apart, undo the nuts and bolts on there, and you can stow the anchor flat. You wouldn't arrange it in a hurry, but if you want to stow it, then you can. And the Knox is a Scottish developed by Professor Knox of Edinburgh University and manufactured in Scotland. Let's talk about performance of anchors and testing. This question of measuring the performance of anchors and how well they work is a bit like religion and politics. Everybody has their own idea and thinks that everybody else is wrong. However, we can get away from the tradition and look a little bit at the science and say, okay, in science, how do we do an experiment? Well, a scientifically designed experiment is designed to test something against some measurable parameters, with replicate testing to overcome fluke and spurious results. And it takes into account, and such an anchor test needs to take into account the fact that different anchors are different sizes, and therefore you can't measure a tiny anchor of one brand against a large anchor against another one without some sort of compensation for the size change. This particular test is a pull test on a beach using a load scale and a computer to record the results, and the winch puts some strain on the chain and pulls the anchor from a peg. You can just see in the top left picture, there's a pin in the sand as the starting point and the measuring point from which to measure the distances. But there happens to be a shell on the beach in these pictures, and so you can see that that anchor is embedding itself fully and burying itself within 2 anchor lengths of the starting point. So the starting point at top left picture, next to the right, it's starting to embed, and then it's starting to dig in. It's nearly buried in the 4th picture, 5th, 6th, and 7th, and you get to the 8th picture, and the whole anchor is embedded in the sand, completely buried. And the chain itself that's pulling it is probably still lying along the seabed, with the last couple of meters nearest to the anchor starting to bury to where the anchor is. So this is the best way that an anchor will develop the highest holding power, is to bury itself very quickly. Of course, it's clear that it needs to embed on its own without disengaging from the seabed, and measuring the force on this anchor can allow us to develop some graphs that can measure one anchor's performance against another, and then replicate tests can avoid any spurious results by taking some averaging. Here's such a graph showing the static holding force, and this is defined as being the force at which the force that the anchor will withstand on the chain without moving in the sand. Clearly, if you apply enough force, any anchor will start moving along under the sand. But what is the force that you can apply until it starts doing that? Mostly when the anchor does start to move in the sand, then there's some change in the force, because nature with the wind and the waves and so on means that the force is very variable. And so that relaxes, and then it holds for a while, and then it starts to plow along under the sand again. Excuse me. So if you measure the force and you can convert that into static holding force divided by the weight to give an accommodation for the fact that different anchors are different sizes, you can start to graph different anchors together and you can measure their performance. The 2 top graphs that achieve about 40 of efficiency are new generation anchors, and the other 3 there are older generation anchors. You can see that they develop a lot less holding power. Older designs here, we demonstrate which are which. The Bruce develops about 5 times its own weight in holding power and then is fairly steady. That's the black graph. The bottom blue graph is interesting. This is a 21.5 kilo CQR. Remember, the fact that the different weights is taken account of by the fact that we're dividing the static holding force by the weight to give a measure of efficiency. The CQR develops an increasing force and then a decreasing force and then an increasing, and if you keep going, it will keep cycling like that. And the reason is that it starts to dig into the sand and then it starts to come to the surface again. It's not quite known why, but that's the performance that it does on average over many tests. The new generation anchors, however, continue to increase their force until they level out at typically about 35 to 40 times their own weight in terms of the static holding force. There's some important conclusions that come from the scientific approach of measuring performance of anchors, and these are they. It's only possible to test anchors against each other in the same conditions. Replicate testing must be done to avoid chance outcomes. By chance outcomes, I mean things like, for example, an anchor might have its fluke tip just strike a small stone embedded in the sand, and that would give a spurious result. No anchor performs well in every situation, and this is certainly true, and those that have tried to anchor in kelp will know how difficult that is, that no particular anchor performs very well in kelp. Some anchors generally outperform others. By generally, we mean over the average of conditions. Modern designs outperform older designs by 4 to 8 times. Now, this is really quite a dramatic level of performance difference. But then that's typical of technology. If you take a 1960 Morris Minor and compare that with a car of 2020, then it's probably 4 to 5 times less efficient in lots of different ways. And so it is with anchors. And it's certainly true to say this anchor has done me for 25 or 30 years and it seems to have done okay. That's certainly true, but then you're missing out on the possibility that you could have that increased performance, should you want it. But performance is relative to the total weight of the anchor. Clearly, if your anchor weighs 5 tons, then it will hold a leisure boat very comfortably. You just won't be able to take it with you. And a very lightweight anchor of 1 kilo probably wouldn't hold it. So the performance is relative to the total weight of the anchor or the size of it. And you need to choose an anchor that's appropriate for the size of the boat. Each manufacturer has their own schedule of what size boat suits what size of anchor that they make. The best test of any anchor, though, is a long-term trial over a year or more in a variety of conditions, and getting to know your own anchor is the best way. Let's talk now about anchoring. Having covered anchors and their development, we'll talk about the objectives, the technique, catenary, chain or rope or both, or why, holding power and forces on boat, and systems of checking that your anchor is holding. This picture is taken in the Southern Ocean and the wind is gusting 40 to 60 knots. And note particularly the direction that the chain takes. It doesn't go straight down, it's at a certain angle to the sea, and we could imagine that under the sea it's in a straight line, almost as straight as that is there. There is a very slight curve to it because the chain has weight, but the stronger the force applied on an anchor chain, then the straighter it will be. And we'll talk about catenary in a moment. But a point about this to note is that there is probably next to no anchor chain lying on the seabed. Would be less than a meter, if any. In other words, the anchor is doing all the holding. The objective of anchoring is very simple. It's to hold the boat stationary, despite the wind and the current. But stationary is a relative term when we're talking about this in the sea, and clearly the fact that you're tied to a stationary object, hopefully stationary, the anchor, by a flexible link between you and the anchor, the boat and the anchor, the chain or the rope, then you're going to have some movement. And in fact, you could end up being at the end of the radius from a center point, which is your anchor. And you could be anywhere in a circle, the length of your anchor chain, all around that anchor. But generally, our objective is to stop somewhere, perhaps for lunch or perhaps for overnight or for some other stop. And you want to stop and hope that the boat would stay in the same place. Here's a generally accepted technique. There are variations on this, of course, but here's one. Find the anchoring position first. Think about things like wind exposure and check what the forecast is. You might start anchoring in a northerly wind, for example, and the forecast says the wind is going to go round to the west overnight. So wherever you put your anchor and your boat is hanging to the south of that in the northerly wind, remember that it's going to be to the east of it when the wind goes round to the west. Consider the depth of water. If you go and anchor somewhere at mid-tide, what will the depth be at low tide? Is there still going to be enough water? What is the rise and fall of the tide in that place? It varies from place to place, and so you need to have consulted the tides timetable to know what is the time of the tide now, and what will be the height of the tide at high tide. Will I have enough anchor rode out? And what about at low tide? Will there be enough water? Consider where you want to lie after running out your rode. So you put your anchor down and you back off from the anchor to allow some chain out. Where will the boat now sit? And where will it swing to if the wind swings around? You get into position where you want the anchor to lie as opposed to the boat, and you stop the engine and lie at a dead stop in the water. That's easier said than done, because if there's a wind then you're going to be moving anyway, but try to come to a stop, which may of course mean idling into the wind. And maybe this needs two people. Drop the anchor until it hits the bottom and pay out just a metre or two, not much more. But as the wind drifts the boat backwards, or possibly the tide, then you start to slowly pay out the rode. What you don't want to do is to pile up a whole lot of chain on top of the anchor that you've just dropped. And that's the reason for not letting out too much to start with. So drop the anchor until it hits the bottom, and wait for the boat to start moving before paying out some more chain. When all the rode is out, and we'll talk about how much to put out in a moment, make it fast and wait a minute. And I mean a full minute. Wait for 60 seconds. Just take your time with anchoring. Engage reverse and leave it in idle, so that you should just be taking up the strain, taking up the slack, and lying the boat along the line that you want it to be. Next, after a minute or two, increase revs in reverse to about 1/3 to half full power. As you do this, the anchor line will come tight and put all this force that your engine's developing onto your anchor. And if you've got a good design anchor, it will start to dig in, like we saw in those pictures on the beach, and bury itself. That should hold your boat at 1/3 to half power. If it doesn't, get another anchor or try again. Sit like this for a minute or so and see if you're moving. Watch the land. Take a couple of transits or something to see. Line up your position on some marks or something and say, am I moving backwards? If you are, then the anchor's not set, it's dragging, and you need to start again. Here's a schematic, a bit rough, but how much rode do you put out? It depends on the depth and the conditions. So here you have the anchor digging in, the boat sitting idling in reverse, downwind of the anchor, and pulling reasonably hard on the anchor chain to try and dig the anchor in. To start with, you want to put out at least 3 times, and you probably never want to anchor with less than 3 times the depth. If you're staying overnight, then 5 times the depth is probably a good amount of chain to put out. And if it's going to be quite windy, then 7 or 8 times might be suitable. The amount that you put out changes the angle that the anchor is pulled at. And this is the reason for putting out anything more than just the depth. Here at the top, we have a plow type anchor. That means like a CQR or a delta. And in the middle set of 3 drawings, a claw, like a Bruce anchor. And at the bottom, a scoop type anchor. Perhaps you could call these a new generation anchor. The angle of pull is always the same on these 3, depending on the scope. So if you have just 2-to-1 scope, in other words, twice as much chain out as the depth of water, then the angle of pull is going to be about 30 degrees. And if you increase that to 5-to-1 scope on the left side of the screen, then you're down to about 10 or 11 degrees, nearly 12 degrees of angle of pull. The ideal angle of pull would be 0, but that's not possible unless you have anchor chain lying on the seabed. And that's not usually the case unless there's no wind. So you need to have a compromise here, but you can see that the scoop type anchor is going to dig much deeper at a 5-to-1 scope than it will at a 2-to-1 scope. And if you look to the top, the plow type or CQR anchor, at 2-to-1 scope, it's pulling out of the seabed. You can see the angle of the buried bit in the sand is on an angle where it's going to just pull free of the sand and skip along the bottom. In other words, it won't work at 2-to-1 scope. At 3-to-1 it might work a little bit, and that's probably good enough for a lunch stop, but 5-to-1 is more appropriate for an overnight anchoring. In terms of scope, consider the total length of chain that you've put out, and hopefully you might have put some markers on your chain to allow for that, to allow you to count how much chain you've put out. But think of the depth as the point where the chain leaves the boat. In other words, it might be a bow roller or a stem head. That's the point of measuring the depth from, not the depth under the keel, not the depth of water to the surface of the water, the depth from the bottom, that is to say the seabed, to the point where the anchor leaves the boat. That's the depth that you need to consider in terms of thinking about what is 5-to-1 scope. So if you're in 5 meters of water from the stem head or from the bow roller down to the seabed, if that's 5 meters, put out 25 meters of chain. Let's talk about catenary. This word means the curve that a suspended chain makes. So a chain or a rope, if you suspend it from both points, both ends, and allow it to hang in air or in water, it forms what's known as a catenary. The harder you pull it, the closer it approaches to a straight line. In theory, it never gets to a straight line. In practice, it might look as straight as you could see. And if you put virtually no force on it, then of course the chain hangs almost vertically down to the seabed and along the bottom. So boat A is sitting at 5 knots of wind speed, and he has a rather slack anchor chain falling to the bottom and along the seabed. And this is the ideal angle of pull on the anchor, of course, but there's not much pull because there's not much force on the boat. So catenary, excuse me, catenary is most effective and mostly there when you least need it. Contrast that with boat C, where it's sitting at 40 knots of wind. The anchor chain is almost a straight line. There's almost no catenary, and this is when you might want it most. The effective catenary is to give you a shock absorber. You can see that boat B, sitting at about 10 or 20 knots of wind or so, has this curve of anchor line which can straighten out to give you some accommodation of snatching type effect that gusts of wind might create. So as you go from B to C and the anchor line goes from curved to straight, then you've got a little bit of extra, about the length of the boat or so in this case, in this sketch, you've got some extra length that gives you some flexibility. And what this does is prevent a snatching action on the anchor line. But when you get to the point of boat C, this doesn't exist. So catenary is a great idea, and people will tell you all sorts of stories about how you need to have catenary. It is true that it's effective, but it's most effective when you least need it. A tripping line. Here's another technique that can be very useful. You don't know what you're anchoring in. You might have a chart that tells you it's sandy bottom, but is there an old tire down there? Is there a wreck of an old boat, or is there an old mooring chain or something? And so you put your anchor down and you hope to retrieve it later, but it might get stuck. And you pull on the red line, your main chain, and you find you can't get it. Now, a way to handle that is to put what's called a tripping line on there, a buoyed line, which is just a rope that you might have aboard the boat. Tie it to the other end of the anchor than where the chain is, not as it's shown in this sketch. Tie it to the back end of the anchor, to the flukes, and most anchors have a place specifically for this point, and have on the other end of the rope a float. Make the rope about the length of the depth of water to the surface of the water, suitable for high tide. If you make it too long, then this buoy is going to float back around your boat with the possibility of wrapping around your propeller or your rudder. You don't want that. You want it just to show where your anchor is. And the purpose of it is that if your anchor got stuck, you can motor forward, pick up the buoy, and pick up the anchor backwards and unhook it from whatever it might be hooked in. Here's what you might get hooked in. Who knows? This picture's taken underwater, and you can see that the anchor has pulled along the bottom and got stuck into this concrete block, and retrieving that anchor might be quite tricky. Equally, the anchor might have just fouled on an old mooring chain or something like that, but pulling it up backwards by a tripping line would be a way of retrieving it. What should your anchor line be made of? Here's some Navy people examining the anchor chain of a boat and having a good close look at it. And notice how they've painted some links to give a code that shows them what the length of chain that is out so far. This is a reasonable way of showing some markers on chains. Another way of doing that is to put cable ties on there. Not so great to put plastic in the sea though. Another way is to tie bits of string or even leather bootlaces on links marked out to some system that you can recognize, and typically you want them about every 5 meters or so. So at 5 meters, 10 meters, 15 and so on, you know how much chain you put out. So back where we anchored in 5 meters of water to the stem head, then 25 meters is 5 of those knotted lines or boot leathers or whatever they might be. But why chain? Why not rope? And here on the left we show a Danforth anchor with a short length of chain and then a long length of rope. And that works, that's fine. There's no essential reason to use chain only. But there are things to consider, and the first one is abrasion. The anchor is going to bury itself in the sand, and the sand isn't just clean, fine sand. It's got rocks and sharp flints and all sorts of other stuff in there. And so there will be some abrasion. And so a chain is good to withstand abrasion. A chain has no stretch, however, and some stretch would be an advantage because it would remove some shock loading on the anchor. So you can use a combination. You can use all rope. If you don't use your anchor very often, then all rope is an adequate way to do it. And one thing to bear in mind is that chain, of course, is heavy. And so you put the chain in the bow of the boat and you've got all that weight of that chain. You might have 50 or 60 meters of it. And that might be quite an extensive weight to have in the bow of the boat. Only you can decide what you're doing here because it's appropriate to what you yourself do in terms of your anchoring. If you're anchoring all the time, most likely you need chain because that's the most versatile in terms of abrasion and so on, and will last longest. There is another way that you can put a piece of rope into an anchor line that is all chain, and we'll come to that in a moment. But what we're going to talk about now is anchoring forces. And here I'll just give you one example to be an example. A 12-meter boat, about 40 foot, in a force 8 gale, exerts about 400 kilos of force on the road. That might be the rope or the chain, of course. So your anchor needs to resist a pull of about double that to give you some safety margin. In other words, 12-meter boat needs an anchor that's capable of having a resistance to pull of some 700 or 800 kilos, something like that. And of course your anchor rod must be able to withstand that too. So the chain needs to be able to withstand that, or if you use rope, that too. But to give you some reference here, reference points, an 8mm diameter chain has a proof load, that is the test load, of 20 tons. In other words, it's quite reasonable to assume that it will do a 20-ton lift. It has a breaking point of about 40 tons, about double that. And there's the figures for a 10mm chain, 30 tons and 63 tons. This is typical grade 40 chain. There are other higher grades available, and so you can have an even higher resistance to pull for your anchor rod. So 20 tons is plenty. That's well over the 800 kilos we said we probably should have, 20 times it or more. But a new generation anchor of about, say, 20 kilos and a holding power of about 35 times that is going to give you about 700 kilos. So this gives you a way of sizing an anchor for a boat. 12-meter boat is going to pull 400 kilos on its anchor, and To give you some safety, you want more than that, perhaps as much as double. A 20 kilo new generation anchor should give you about a 700 kilos resistance before it starts to plow through the sand along the bottom. Even when it plows, it's only going to move a few meters, but the best is that you can have it that it buries itself and doesn't do much more than that. This gives you some idea of the sort of force involved. Another way to look at this is that your engine needs to develop about 400 kilos of force to stand still in a force 8 gale if you were just using your engine to maintain a stationary place. And your engine would need to develop more than 400 kilos of force on the boat to make any forward progress in force 8. This gives you some perspective of knowing what sort of force is applied onto an anchor. Here's another way of looking at this with the boat along the bottom axis of this graph and up the left axis, the force in newtons, which we could call kilos. So on the left, if I get my mouse working here, if I take my 10-meter boat in green up here, a 20 knot wind, this green line here, take that back to here, it's somewhere between a 0 and 200, let's call it 100. So there's about 100 kilos of force at 20 knots of wind. Go up to 35 knots and I've got about 300 kilos of force. And on my 10-meter boat at 50 knots, storm force winds, 600 kilos of force is being exerted on the anchor. So this gives you some idea of the resistance to pull that an anchor requires to develop. This shock loading that I talked about earlier can be absorbed even when you're using a fully chain anchor rode with this method. It's called a snubber. You have a little hook that will hook into the chain and hold the chain at that point, and you use a nylon rope and it needs to be about the length of the boat. A snubber that's only 2 meters long is almost useless. It's almost a waste of time using it. You'll get very little stretch out of that. You get about 10 or 20% stretch in a piece of nylon rope, and if you have one that's about the length of the boat, let's call your boat 10 meters long, so you've got about 10 meters of nylon rope out there, you're going to get at least a meter and perhaps 1.5 meters or 2 meters of stretch backwards and forwards, accommodating the shock loading that your boat will apply because of gusts of wind onto the anchor rode. And this will avoid the anchor being subjected to this shock loading. So a snubber is a very useful thing to have on a boat, and nylon is the type of rope to use for this, not polyester. And the reason for that is that nylon is very elastic compared to polyester. Nylon does have a disadvantage though, is that it's not very UV resistant, so don't leave it out in the sun forever. Stow it away when you're not using it. How do you check your position when you are anchored? So you've put your anchor down, you've backed up on it, you've dug the anchor in, you've made it all secure, you've fitted your snubber, and you're ready for the night. How will we know that whether we've moved or not? On the left-hand side, we've got a boat anchoring off a little island, and he's taken several different sightings by lining things up. Notice here he's lined up a church. This is the symbol for a church building, and a windmill tower behind that on this island. And he's lined those up. And if he stays on that line, then he knows that he hasn't moved in this direction here. He hasn't moved at 90 degrees to the... And that's all very well, but what if he's moving this direction here? Then they would still be in line. So that's why he's taken also a couple of other sightings here across this buoy to a boat anchored further over here. Looks like a lighthouse boat. And he's taken across the top of a wreck here to the summit of that island. So he's taken several sightings of lining up some transits, as they're called. And so if they move, then actually he's moved. This is perhaps better explained in this picture here, where we can see that we're off the line of these two marks. So if we'd taken a line of these two marks, then we've moved to the left. The white mark hasn't moved to the right, they don't move. If the things are not in line anymore, then we're not in line. So lining up two stationary objects is one way to do it. You can, of course, use a compass. If you get your hand-bearing compass out, you could take a bearing on the summit of this island, 148 meters high, and there's Laura Island. You could take a bearing on that and say there's one mark, and this way you can get some bearings from things that don't move, and you don't need two of them to line them up. Whichever of these methods that you use doesn't matter, but use something that will work. You can, of course, get phone apps, and as long as you have the GPS turned on, then they will tell you whether you've moved a certain distance from your position where you put the anchor down, and they'll call an alarm. That's provided you've got enough battery in your phone, and so you need to think about these sort of issues. Some GPS systems built into a boat have a GPS anchoring alarm, and you can set in a distance and say, if I move more than 10 meters from this spot, then start the alarm up and wake me up in the middle of the night, because it looks like we've moved and our anchor's not holding. Whichever of the methods you use doesn't matter, but use some method. Don't just put the anchor down and head off to sleep and think that everything will be all right, because it might not, and you want some way to check. So if you wake up during the night, you want a way to look out into the cockpit and say, are we still in the same place? If the answer is yes, go back and get back to sleep. Let's talk about anchorages and where you might anchor. How do you choose an anchorage? How do you choose where to anchor? Clearly, there's got to be sufficient depth or lack of depth to anchor in, but where would you get the sources of information about which are sensible and safe anchorages, and what might we see? In choosing where you're going to anchor for the night, here we've anchored on our way on a trip here on one of the small islands. And we've made a cup of tea, made a meal, and being prepared, getting ready to go to bed. The fact that there were some others nearby was a good idea. That can be good. That shows that others have anchored here, and if you've never anchored in this place before, that might be one way of recognizing that this might be a favorite anchorage. What about the tide? Is there any tidal height problems for us? What's the state of the tide at the time that we're anchoring? If we anchor at high tide in 4 meters of water and say that, well, that's plenty of water for us, but there's a 6 meter rise and fall of tide, then there's going to be no water at low tide. You're going to be on the beach. So that's no use. If we anchor at low tide and there's a 6 meter height of tide, then we're going to be in 6 meters deeper water by high tide, and did we put enough anchor line out? So in considering your scope, think about that scope in relative to high tide, not low tide. Too much scope is not a problem other than the swinging room. What about the tidal flow? Is there any flow of tide through here? And if there's any current, what will that mean? Where will we swing if there's a current and no wind? What's the forecast? The forecast for no wind all night, or is the wind going to change during the night? And if it changes, then we'll start lying at a different position in relative to our anchor. So if we were to swing on our anchor 180 degrees from where we are here, if the wind had changed 180 degrees, we'd probably end up where that red buoy is. And that might be a problem. Bump, bump in the night, that buoy's going to be touching the boat, scratching the paintwork and causing other problems. What about other traffic, ferry movements and such like? If you anchor in a place where the ferry needs to turn on its approach coming into a ferry landing, then they won't appreciate you being anchored there. There might be other traffic happening. There might be people coming in late at night, later than you. They've been sailing through to midnight, 1 o'clock in the morning, decide that they'll come and anchor in the same anchorage that you're in. Did you leave your anchor light on? If you've got a masthead anchor light, then please use it, because it's not for your benefit, it's for the benefit of others that might come in the middle of the night to know where you are. What about fishing boats? Fishing boats typically will come in after dark and they'll leave before daylight again. If they're going to come in and anchor, then they won't be there all that long. They'll probably get a short sleep and be away again. So there's movements of other boats and things. All of these things are things to consider in choosing an anchorage. Mostly I like to choose a nice quiet anchorage. You want a quiet night's sleep, so you want shelter, you want to be away from the wind, away from the tide, away from other boats, away from ferry movements and all these other things. But if you have to anchor it somewhere, then take all of these things into account. This happens to be the anchorage on the west coast known as Pooldoran, the Otter Pool. And the picture here is to give us the thought of thinking about swinging room. Notice these boats on the right are swinging in one direction to their anchor, and the two on the left, or the three on the left, are in a different direction. A boat might lie to the wind from its anchor if there's enough wind and no current, or if there's no wind and only current, then it might lie to the tide. So if you're anchoring in a tidal area where there's a tidal flow, then you're going to end up hanging downstream from your anchor if there's no wind. And if you've got both, then it's going to be a fight between the wind and the tide to tell which way you end up lying from your anchor. But in all of these, you need to consider what's called swinging room. So if you think of your anchor as being the center of a circle and your anchor chain is the radius, draw a circle around your anchor at that radius, and that's your swinging room. That's the place that you could be ending up anytime during the night. If there are other boats also in that circle, then that could be a problem. Generally speaking, boats will all swing in the same direction if they're all subject to the same forces, either the wind or the tide. So they will all point in the same directions, and so the swinging room can overlap slightly, but not too much. Sources of information. In the west of Scotland, then these are probably the best sources of information. I would say that because I help with them. But these are written by people that are experienced in sailing on the west coast of Scotland and in these areas, and with input from a large number of people in the Clyde Cruising Club feeding information in about anchorages. They give you sailing directions on how to get from one place to the next, all about tides and winds and rocks and routes and obstacles and everything else like that, and lots of information about anchorages. So these are a good source of information for the cruisers on the west coast of Scotland. They come in these 5 main books, the lower 5, which give you specific information about those areas, and the central book, Cruising Scotland, at the top of the page, gives you background information about the places that you might see. Where might you go? So if you anchor there where that boat is shown, what's that church that's on the shore? And can we go there and can we visit it? This Cruising Scotland information gives you all of that sort of background. The Firth of Clyde is onto its 3rd edition, and it's just out last month. This is the 2020 edition. It arrived in Glasgow just this month from the printer. And you might say, well, surely this information doesn't change. Well, that's not true. It does change. Not only do new rocks get discovered, usually by people who don't want to admit that they've discovered them, but newfound rocks do get discovered and charts get updated. But more importantly, lots of other information changes. This particular picture is taken in the Kyles of Butte, and the markers in there have changed a number of times over the years. So buoyage and marker posts do change from time to time. They don't last forever. They get changed in their position, their color, their light sequences, and so on. Lighthouses change, facilities ashore change, marinas get added, some marinas occasionally go away. Things come, things go, and so an up-to-date version of these is good information on where to anchor on the west coast of Scotland. Now I want to take you on to looking at charting and charts and where we might think about anchorages and getting information. This is what's known as the Cumbrae Elbow, or the main route into the north end of the Firth of Clyde, from the south, and all of the shipping over the last couple of centuries has probably gone through this gap. But just on the island of Butte, the main island on the left, and near this lighthouse where we can see this little red light here, red beacon, there's a nice little bay that's a good anchorage. Glen Callum Bay it's called. This is the Admiralty chart, and we can see on this chart how much information we get in terms of an anchorage. There's plenty of suitable information to tell us that we should be heading at 11 degrees up this line here. That's the shipping line, the main line for a ship heading into there. Between this lighthouse and that lighthouse, plenty of room for a ship to go through here and even past another one coming the other way. But we're wanting to go about an anchorage, but we don't get a lot of information. We can see that it looks like it might be okay. It might be quite a nice little anchorage, but I can see just there, and you see where I'm pointing with my my mouse, just there's a rock. It does show an anchor symbol there, so it suggests that there's an anchorage, and the depth looks probably about right, 8, 5, 2.5 meters. So that sounds like it'd be quite good. If there's 2.5 meters at low tide, that would suit my boat quite nicely. Can I go and anchor there? But there's not enough information. So that's Admiralty charts, limited information in this respect. But let me show you another type of chart called the Antares charts. And this is the same bay on the Antares charts. Not only does it give us a lot more information in contours, here you can see there's the 4, the 3, and so on, 2 meter contours, but it also gives us information about the bottom. Up here on the left is some information that tells you which tidal chart to use, which tidal prediction. You use Millport for this one, for example. It tells you something about the bottom, nature of the bottom, and you see this dotted line drawn in here. It says best sediment for anchoring within dashed line. So the best place to anchor is right here or right there. You might have been otherwise tempted to go in here and anchor here because that's what the chart would show, but notice that it says rocks and stones on the seabed. The Antares charts give you a huge amount of detail compared to what the Admiralty charts give you. Let me look at one other anchorage here to demonstrate this. This is just adjacent to where we were. Just go back a moment. So over here is Little Cumbria Island. We were just looking here, and so we're only a mile or two away at Little Cumbria. And on the western side here, there's no suitable anchorages. But on the eastern side of this island, there's this little bay here. And this is the information we've got. We can see that there's a bit of some islands here and some rocks and a very shallow bit here, 0.7 meters, but 6 meters here, 10 meters, 2.5. It looks like a reasonable place to anchor, but not a lot of detail to get in there. Here's the Antares chart for it, and we've got a lot of information there. But I want to show you the Antares chart live, and so I'm going to move to a charting program, if I can get there, like this. And here's where we're talking about. This is the Firth of Clyde, and we were talking about Glen Callum Bay over here, and the Antares chart for that. And I want to show you this chart here. So if I go to the best chart, and I can bring this in and I can zoom into it. And I can move the chart around on the screen like this. So plenty of water outside here, 20 meters or so. And we would, if we were coming from the south, we would come around here and you would be coming in this direction, heading into this bay. But here, because you've got this chart, you now know that there's this rock here, 0.7 meters. I've seen this rock awash once and I can verify that it's certainly there, but Antares charts have checked it and know that it's there according to their sonar and side scan and so on. So here's this nice anchorage, and you can see the level of detail that we've got in here. We might come in here and anchor somewhere in here. We know there's a shallow bit here, only 1.5 meters, little hump that's just in there. But there's a nice reasonable area here for anchoring in anywhere between 2 and 5 or 6 meters. You might anchor in this little area here. You might even anchor up in here, depending on how much swinging room you need. But you can see that that's a reasonable anchorage, and you can see the level of detail that the Antares charts give us. On the Admiralty chart, it did show a disused cable across here, and this is the line that it is reported to have been in, but actually nobody's ever discovered this. So in terms of fouling it with your anchor, if you knew you were going to drop your anchor right on that line, and this would give you a very good reason to use a tripping line. Here's the level of information that Antares charts are going to give us. This useful anchorage offers good shelter from the west, although there can be a tide-induced swell. Exercise great care if approaching from the south. At the time of the survey, official charts showed 5.2 meters of water here, where we show 0.7 north of the Trail Islands. Take great care of using old charts. So this is the point I was making about coming in from the south. Admiralty charts up until recently showed 5 meters of water in this area here. Clearly there isn't 5 meters. This little promontory sticks out here underwater, and you could run foul of that quite easily. It was actually because of Antares charts discovering it that the Admiralty chart was updated. Directions: access to the main anchorage is easy, but don't cut the corners, especially from the south. Our chart shows the reported route of a disused electricity cable. We could find no evidence of it, and we would appreciate feedback from anybody that might know one way or the other. The area north and northwest of Broad Island may offer better shelter from swell, but it's quite compact. For height predictions, use Millport. No noticeable tidal streams within the anchorage. So here you have information that can answer the questions that we said before that were a good idea to consider. So he talks about this little area to the north might be a nice anchorage somewhere in here, but recognize that shallow spot here. You might be able to anchor just in here, perhaps in here, depending on how much water your boat requires. So there's Antares charts, and let me just go back a stage here, even further. And I want to show you the extent of the Antares charts. I'm zooming out here to give you this whole area of the Firth of Clyde, and you can see that to the north we've got a number. Each of these red areas here is an Antares chart. And if I click on this one and go to the best chart, that'll show me that particular chart, that little anchorage place just in there. And you can see the level of detail that's there. So going back to here, then you can see there, and I want to take you back even a little further still and take you onto this list. So we were looking at just this area to the right, but lower. We were looking at this area, but you can see that there's another set of charts in this area here. Look at the number that are all in here. Up around Oban, all around the Isle of Mull, Colin, Tyree, Small Isles, Skye, Western Isles, lots of these charts. And these charts just cover the nice little anchorages. So these are not marinas, these are not places that you're going to go and find that it's full of people. If you go and anchor in the Shiant Islands, for example, nobody lives there, so it's going to be a deserted area. And here's the Antares charts for this area. You notice that the chart only gives you the bits that you need. The grey area is assumed that you can use the Admiralty chart for that because there's plenty of good information on there. But if you want to zoom in and find out what it's like in here, look, you wouldn't want to anchor here, mainly stony or rocky inside the dashed line. So you can find a place to anchor here. I wouldn't anchor there, it's a bit deep, 13 meters. You might anchor here, 8 or 9 meters, perhaps for lunch while you went ashore and did some exploring. Strong tidal streams in this gap here, so maybe not a good place to anchor. What about down this side here? Is there somewhere here? Yeah, there's some nice anchorages here, but he says it's mainly stony or rocky inside the dashed line here. So you need to actually anchor in 10 meters of water or more. That's quite a lot. That means you're going to have 40 meters of chain out perhaps. So zooming back out of there, it doesn't look like this is a great place to anchor. Is there anywhere? Over here might be the best, mainly stony or rocky inside the dashed line, but it's sandy here in 14 or 15 meters. So you could anchor here, but it's quite on the deep side. So that's the Western Isles, and I move over here, there's the rest of Scotland, giving you some idea of the Antares charts. Now I'm going to go back to the presentation and just remind you that these sources of information which integrate with the Antares charts are available. You can buy these from the Clyde Cruising Club or from Chandler's or directly from the publishers Imre. And Antares charts information is available from this website, antarescharts.co.uk. There are 523 charts that cover the west coast of Scotland, and the number is increasing each year, although this year there won't be much of an increase, I don't think. This chart system integrates well with the following mapping systems, memory maps. I was using CClear in what I just did a few moments ago, but there are other systems like OpenCPN is a very popular system. These are mostly computer, tablet, or phone-based charting systems. Antares charts don't work with a built-in chart plotter using the likes of Navionics or some other system like that. So that's Antares charts. So that covers where might you go and what information can you get to discover where you might go anchoring. So that's brought us to the end, and I hope that's been useful. Next week's presentation is about anchoring in a blow with Paul McNeil, and so you're welcome to come next week as well. We hope you do. Bye for now.